Hello! In this video we're going to be looking at combinations. This is something you'd see in the first couple of weeks of a finite class, for example at Indiana University in M118. Currently you see it about week 3. This corresponds to section 2.3, Counting Partitions Combinations, in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. In this video, we're going to be looking at one of the recommended problems that one of the instructors has given us, and I think it's a pretty fun problem. This is a big thing to get comfortable with. Coming up in this class, you're going to start looking at probabilities, and combinations, and the thing we went over in the last video, permutations are a really big deal in probabilities, so getting comfortable with this going to be very useful. So with that being said, let's go ahead and start reading off the problem and see where we can go from there. So the problem I'm looking at is number 27. I chose this one because it's a really common kind of problem you're going to see. It's a game of chance problem dealing with cards. It's kind of funny. One of the things I always see in finite classes is when you come in they say you really need to know your cards. And you wouldn't really expect that in a math class, but this kind of proves the case. So before I even read the problem, you should know that there are 52 cards in a standard deck. There are 4 different suites, and there are 13 of cards in each suite. So kind of important to get that understanding before we even get started. So we're looking at number 27, and I'm going to break it down. So a hand consists of sets of 5 cards selected from an ordinary deck of 52 cards. Part A, how many different hands contain exactly 3 spades? Okay. Part B, how many different hands contain exactly 3 cards of some suite? Any of the 4 suits. Okay. And then part C, how many different hands contain cards of all 4 suits? Well, that sounds pretty crazy, but it's not so bad. We're going to break this down into actually 3 kind of mini problems, quote unquote. And so let's look at the first one. How many different hands contain exactly 3 spades? And the first thing I'd like to do before we do anything else is write down what we know. So this seems a little silly, but bear with me. We're going to say there are 52 cards total. And there are 4 suits, and in each of these suits is 13 cards. And I'm writing this down because we're going to use these numbers over and over and over again, and it'll be kind of handy. So let's go ahead and look at part A of this problem. So part A asks us to say how many hands contain exactly 3 spades. So exactly is one of those keywords that you should really be paying attention to, because that's kind of a big deal. So this one's actually pretty straightforward. It's going to use a combination. We know that because we are in the combination section, but we also know that because you can't have repetition, order doesn't matter. So you know, in the past in permutations, order matters. When you're talking about combination, order does not matter, but repetition matters, and you can't have any repetition. So let's go ahead and start this. So let's do A. Okay, and we need 3 spades. Actually, exactly 3 spades. Okay, and may not seem like it, but this is a pretty straightforward combination. So one of the other things I like to do is I like to write down the formulas that I need. So I'm going to write that in a nice blue so we can find it. And that is C of n r. So that's n things taken r at a time is n factorial over, and this should look really familiar to the permutation formula. So, you know, you should remember both of them, get them on an index card, look at them constantly, and make them near and dear to you, because we're going to be using this a lot. So the combination of n things taking r at a time is equal to n factorial over n minus r factorial times r factorial. And all of this, just so you're not confused, is on the bottom there. Kind of important. So let's go back to our problem. So we have exactly 3 spades. Okay, well, doesn't seem like it's going to be easy, but kind of totally is. So if we were going to plug 3 spades in, we would take, there's 13 total spades, that's our n, taken 3 at a time, so 3 is our r, times 3, whoops, don't forget your factorials like I like to do, 3 factorial. But that's not it. So this is a 5-card hand, and it takes exactly 3 spades. So that means, and there are going to be, and I'm gonna do this kind of in reverse. There's going to be some number of cards taken 2 at a time, right? Because otherwise, we're not counting those. And those are kind of important. And we don't have to count spades in this, so this is where this whole concept of how many cards in a deck there are kind of useful. So if there are 52 cards total in a deck, there are 4 suites, 13 cards in each suite, and we have already used the spades, that means that we can use any card that's not a spade, or 39 remaining cards, so that is 52 minus 13, so that's 39 cards taken 2 at a time. And we multiply them because and is multiplication, or is addition. So we take 3 cards from spades and 2 cards from the rest of the deck. And that's all this is saying. It might seem a little intimidating, but this is saying, 3 cards from spades and 3 cards, or 2 cards from the rest of the deck. And this is a really common problem, so get kind of comfortable with it. Let's go ahead and do the math. At this point, you should be getting pretty comfortable with the algebra behind this, so I'm actually just going to kind of run through it really fast on this one, and the other ones I might go ahead and skip some of these, because you should be getting comfortable with factorials and basic algebra. If you're not, check out some of the other videos online. There's tons of algebra help out there. It's just something you got to get used to. So let's see, 13 factorial would be, 13 times 12 times 11 times 10 factorial over 10 factorial, that's this bit right there, right? Times 3 times 2 times 1 times, oops, and I missed a factorial here, 39 times 38 times 37 factorial. And this is actually how I do these on tests. Write it all out, because the instructors want to give you the answers, so they want to give you points. Make it easy for them to give you points. Times 2 factorial, oops, I want it to be at 22, and I always, when I have like a 2 factorial, I always write that times 1, so I remember. Okay, so we can do some cancellation here. Let's go ahead and choose a different color so we're not thinking. So 10 factorial cancels out, 3 and 2 cancel into 6, which can cancel this down to 2, and I'm moving pretty fast, so 37 factorial cancels out up here, 2 cancels into 38, which turns into 19, and let's go ahead and write down what we've canceled, and then we'll actually do the math. So, this turned into a much easier problem. The nice thing about combinations is that you typically can clear out everything on the bottom, so it's really not as bad as it looks at first glance. And so once I do this bit, I get 286. That seems a bit off, doesn't it? Let's I'm actually going to pull up a calculator and confirm. Oh, that's because I forgot a 2 right here, and that's totally right. Times, so 39 times 19, and I always break my math down. It's better to break your math down rather than try to, jam it all in there and then be wrong. And so 286 times 741 is 211,926, and that is our answer for part A. I moved really fast on the math there, but as you should see at this point, the hard part is figuring it out. This orange bit up here, this is the hard part, knowing exactly how to do how to set up the problem. Once you get the formulas, the answer, which is down here, should flow pretty easy. And if you find that's not the case, step back, do some review, not a big deal, and I'm sure you're going to get it. So let's look at part 2 of this one. So part B asks us, how many different hands contain exactly 3 cards of some suit, any of the 4 suits? And this might seem like, oh man, this is going to be really rough, but teachers like to ask this one because this one's actually really, really easy. I'm going to do it and then we're going to talk about it. So B, how many contain exactly 3 of any suit? And this is 4 times our previous answer. So that is literally 4 times 211,926, and that equals, oops, 847,704. And why can we do that? Well, up here, I'm going to go to a nice green. Right here, all the stuff we did here, that isn't specific to spades. In that part of it, we were figuring out how many hands contain exactly 3 spades, but nothing in this answer says this only works for spades. So because there are 13 spades in a deck, there are 13 hearts in a deck, there are 13 clubs in a deck, and there are 13 diamonds in a deck, we can just multiply this answer by 4 to get how many hands contain exactly 3 of any suit. So really handy. Teachers like to ask that. Sometimes it's a little tricky, but I like that one. Let's move on to part C. I actually think that one's going to be the trickiest one. Part C is asking us, in how many ways can we make different hands containing cards of all 4 suits? And I'm not gonna lie, I tried about 3 different ways to do this. This one seems tricky, and again, the actual math isn't hard. It's how can you put it together? How can you actually put the question together? And let's go ahead and do that, and hopefully it'll make sense. So let's see. Again, this 4 times is really handy because what we can do is we can figure out the answer for just one of this. In how many ways could we have exactly one of every suite except for, say, hearts, where we have 2, and then we can multiply it by 4. Super handy, really important concept. So let's go ahead and do the math, and we'll go from that. So we're going to do 4 times. And actually, you know what? We're going to come back to the 4 times. I'm going to leave some space, but we're going to come back to that because I think it's important to get the rest of it formulated first. So if I have 5 cards, and this isn't the math part, this is just the explanation part. If I have 5 cards, and let's say, I have a spade and a spade, that means that these other cards, here, here, and here, this has to be a different suite, this has to be a different suite, and this has to be a different suite. Because otherwise, I'm not answering the problem. If all of those are true, then that means I have, 1 spade, 1 heart, 1 club, 1 diamond, and that is what they want. They want at least 1 card from every suit. And so, I can formulate this, can't I? How would I formulate this? Well, if I had a hand that contained from 13 spades, it pulled two cards, right? This is just a basic combination. My 2 is terrible looking. And from, let's say, from the hearts, I pulled exactly 1 card, and from the diamonds, I pulled exactly 1 card, and you should be seeing a pattern here, and we're gonna use that pattern for our own diabolical purposes. And then finally, from what I got, clubs, we're gonna pull exactly 1 card. So what happens when you multiply the same thing by itself 3 times? Well, that turns into, and I like to put brackets, That way nobody ever gets confused. 13 over 13 minus 1 factorial, 1 factorial to the third. So if I had 2 times 2 times 2, that's the same as 2 to the third. And this is just handy to fit it all on the screen. And then we have, 13. So this is we've chosen 2 spades. So 13 minus 2 factorial. And what would happen if we wanted this to be applicable for, what if we chose, 2 hearts? Well, that, and again I'm going to use brackets, we can multiply this whole big thing by 4. And once we figure that out, that's going to be our answer. So let's go ahead and figure that out. So 4 times, and again I'm going to do this one a little bit fast, but I'm going to slow down a little bit because I think it's a little bit to get your brain around. 11 factorial over 11 factorial times 2 times 1 times, and again I'm going to do brackets because that makes our life much easier. Excuse me. 13 factorial over 13 factorial times 1 factorial. Wow, that looks pretty simple. So let's go ahead and cancel some stuff out. Let's see. 11 factorial goes away, 11 factorial goes away. 2 factorial can go into this, 6, so this turns into 4 times. So that 4 is moving down each time, right? 13 times 6 times. So, and again, we can cancel some stuff out. 13 factorial, 13 factorial. So this turns into, well, this has a mistake. I just realized that. And, hey, that's not a big deal. The problem isn't having mistakes. The problem is not, solving them. So what I had done is I had forgotten that right here we have a 13 minus 1. So this is 13 times 12 factorial over 12 factorial times 1 factorial. Still pretty easy, I think you'll agree. 12 factorial cancels out, 12 factorial cancels out. 1 factorial doesn't really do anything. And so then we end up with 13 to the third. And so let's keep on keeping on. So this 4 is going to move on down. 4 times 13 times 6 is 78. 13 to the third is 219. And when you multiply all this together, it would be 685,464. And that's a pretty big number. But that is our answer. So let's go ahead and zoom out and briefly talk about why and what we did here, and hopefully, that'll make some sense. So what did we do? Well, first, I'm going to go ahead and choose a nice blue. First, we wrote down what we know, and that includes the formula. Very, very handy. Write down everything you know. Then we figured out what the question was asking. It is asking how many ways could we have exactly 3 spades. So we figured out what it was. We figured out what the question was in math terms. So we used the combination formula. We did, from a suit of 13 cards, we pulled 3, plugged that into the thing, and from the remaining 39 cards, we pulled 2. We did the math right here, and we got our answer. What did we do on part B and C? In part B, we just used the number we already got, and we multiplied it by 4 because that number wasn't specific to spades. We could use that to figure out, how to do it for hearts or how to do it for diamonds. And then in the final one, we just had to set it up. So we figured out, what kind of situations could we have where at least one card is from each suit, and then we wrote that in math terms, and that's what this ended up being. Here's that 4 again. Super handy if you figure it out for one suit. You can do it for all 4 suits the same way. And then we did the math, and we got the answer. So I want to say something that's not part of this problem, but it kind of harkens back to that whole 4 thing, and I think it's important enough that I'm going to do it in red. So this 4, what if they had asked in how many ways, actually I'm going to go up to the other 4 because it's even easier to kind of get on that one. On part B, what if they had asked how many ways can we have exactly 3 cards from either spades or diamonds. And so instead of a 4, we could have multiplied this by 2. Or what if they'd asked spades, diamonds, and hearts? You could multiply it by 3. So once you figure out, the nice thing about decks of cards, and the reason they use them, is once you figure it out for one suit, you can figure it out for all the suits. Super handy, a little bit of a brain bender, I think. Once you get that kind of concept down, it makes a lot of these problems much faster and much easier. So that's been combinations. Do some practice. I think you'll find them, pretty easy once you memorize the formula, and keep on trying some math. I think you'll like it.